All right. Solving equations number 4. Almost done, guys. So, just a reminder, when we're solving equations, our goal is to isolate the variable. Sorry about the green. I want to use blue, but it's not working very well. There are 2 rules that we need to remember when we are solving equations, and we only need to remember 2 rules. That's what makes it so easy. One of the rules is that equals means the same. That means whatever you do to one side of the equal sign, you do to the other side of the equal sign. So you do the same thing to both sides of this. The second rule is in order to isolate the variable, you're going to have to get rid of some terms, some coefficients, and you do this by using opposite operations. And just a hint, sometimes if you simplify before you start getting rid of stuff, it makes your life easier. All right. Isolate the variables. Equals means the same. Use opposite operations. And sometimes it's helpful to simplify first. Now, solving equations 4 brings us to fractions. I know you guys love fractions. I love fractions. But often it's easiest for us to get rid of fractions so we can work with an equation. So take a look at x over 5 equals 3. This one. I want to isolate the x. I want to get rid of this 5. Now, what operation is happening between the x and the 5? Division. That line means division. The opposite of division is multiplication. So the first thing I do is multiply both sides by 5. After I multiply by 5, what am I left over with? Well, this 5 and this 5 cancel out. They reduce because it's 5 over 5, which gives me 1. Leaves me with 1x. On the right-hand side, I have 3 times 5. That's 15. Holy moly, I'm done already. Maybe fractions aren't so bad after all. Second example is down here. This time, I want to isolate the p. Now, it might be easier for me to just get rid of the 5 and the 9. How do I get rid of divided by 5? I multiply by 5. This 5, this green 5, and this 5 below reduce. So I'm left with 9p. On this other side, I have 5 times 11, 55, divided by 6. Now, I have to get rid of this 9 times p. How do I get rid of 9 times p? I divide by 9. On the other side, I can just multiply the denominator by 9, or also divide by 9. This little dot here means multiplication. So on the right-hand side, I'm left with p. On the left-hand side, I'm left with 55 divided by 54. I just want to talk about this one really quickly. I'm going to change pens. So the first step was multiply by 5. That was so that these 5s on the right-hand side would reduce. The next step here was divide by 9. So that's where this 9 and this 9 came from. Notice, since we already had something in the denominator, we just had to multiply the denominator by 9. It's the same thing by dividing by 9. Next step, we just simplified. All right, more examples. So, multiplying both sides is really easy, except when you add more terms. If you notice in this question, we have 2 terms on the right-hand side. We have c divided by 4, and we have plus 8. Now, I want to multiply both sides of this equation by 4 so I can get rid of this divided by 4. But this time, when I multiply both sides, it's a bit weird. When I multiply this side by 4, really easy, very straightforward. When I multiply this side by 4, I need to distribute. This 4 has to go to every single term. So what I end up with is 4 times 10, and I end up with c over 4 times 4 plus 8 times 4. Now in the future, like when I do the example next to us, I'm probably going to skip this first step. I'm probably not going to show that I distribute everything. I'm just going to remember that I need to multiply every term by the 4 to get rid of it. Now, remember why you multiplied by 4. You did it to get rid of this divided by 4. 4 divided by 4 is 1. These reduce. So you're left with 40 equals c plus 32. Now it looks like an equation that we have seen before. So all I have to do is subtract 32 from both sides. I'm left with 8 equals c. And I'm done. The only part that's complicated about this is this initial step of multiplication. So I'm just going to go over it one more time. Remember, we're trying to get this c by itself. It has attached to it a divided by 4. So the opposite of divided by 4 is multiply by 4. So we have to multiply both sides of this equation by 4, just like we did before. The only thing is that now we have 2 terms on the right-hand side. So we don't just multiply one term by 4, we end up multiplying both terms by 4. You'll notice that we end up multiplying every single term in the equation by 4. This is how we get rid of the denominators. This is how we get rid of the fractions, by multiplication. After that, it's really straightforward. It's just like solving equations 1, 2, or 3. Take a look at the next example. This time, it looks like we have 3 denominators to get rid of. We want to get rid of this 2, this 3, and this 4. The easiest way to do that is multiply every single term by 2, 3, and 4. Actually, it's even easier to just multiply by 3 and 4. Because when you multiply 4 over 2, this is going to reduce to 2. So it's going to get rid of the denominator of 2. So to lighten up my workload, I'm going to multiply everything by 3 and by 4. So I multiply this term by 3 and 4. 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 That was a mouthful. Every single term gets multiplied by the denominators I'm trying to get rid of. So the first step, by just multiplying by your denominators, looks like this. You got to multiply every single term by the denominators you're trying to get rid of. Then cross them out. Get rid of what you're getting rid of. So 4 divided by 2 is 2. With this term, you're left with 2 times 3 times k. Next term, the 3's reduce, so you're left with 4 and k. The next term, you have 2, 3, and 4. Nothing reduces here. 2 times 3 is 6. 6 times 4 is 24. Equals, continue. The 4 and the 4 reduce, so you're left with 3k. In the next term, nothing reduces, so you have 3 times 3 times 4, which is 9 times 4. So that's 36. Now it looks like something we've seen before. The next step is to just simplify. So I get 6k minus 4k plus 24 equals 3k plus 36. I'm going to simplify this side a little bit more. I have 2k plus 24 equals 3k plus 36. I want to get rid of this 2k. So I'm going to subtract 2k from both sides. These ones go away. They equal 0. I'm left with 24 equals 3 minus 2 is 1k plus 36. Now I want to get rid of the 36. The opposite of plus 36 is minus 36. 24 minus 36 is negative 12. Ooh, slow, Miss Manna. And on this side, I'm left with 1k. K equals negative 12. Now, this part, very straightforward and easy. It's all the stuff we've already done before. This first step is the difficult step. What we did was multiplied by denominators. Then we reduced.